So I'm going to actually start the demonstration. It's going to go throughout the duration of the talk. We're going to test the oil beforehand, and we're going to test both samples. So I have 2 hot plates. This is on a higher setting that's a little bit above 300 degrees Fahrenheit. The cooler plate is around 270 degrees. So I did the experiment earlier. We got really nice reaction here and slight reaction here. So I'm going to start them up. I have about a ½ gram each. And Yash is actually we're gonna live stream this onto this monitor right here so we can actually see what's going on.
You have to make sure that you've applied heat at some point for the right amount of time and at the right temperature and in the right conditions to achieve decarboxylation. We're going to dive right into some chemistry on what is it? What is decarboxylation? The plant, cannabis plant itself, produces mainly the acid form of THC. THC is that molecule that gets you high. Okay, it's that molecule that's mostly responsible for what you feel. However, the plant doesn't produce that much THC. What it does produce is THC acid, THCa. That molecule right there, those sticks and stuff. What that is the way the atoms are connected in that molecule, and that's what interacts with the molecules in your body, in your brain, to get you high, right? Except this one is a little bit different from that one. The difference is that COOH group, it's called a functional group. There's an extra bit of atoms. There are an extra 4 atoms. Actually, 3 atoms, 3 atoms here that are not here, right? You guys see those? 1, 2, 3, 4, and then 3 atoms. The COO comes out, and we only have an H left over. So this part of the molecule comes off. That's called decarboxylation. This is carboxylic acid. When that comes off, it's called decarboxylation. That's why it's called that. It's because of that group. It comes off as. Anybody know what it comes off as? What it looks like when it comes out? When it comes off?
Champagne bottles.
Champagne bottles. Yeah. Anything else? Like what is that? What is it though? You've heard of that?
Just the carbon dioxide.
Carbon dioxide. Yeah, it's what we breathe out, right? That's at least in part what we're seeing here. It's CO2. Okay, CO2 is a gas. It's what we exhale. It's really commonly found in the atmosphere, and more these days with global warming and all that. But that's what comes off of the molecule in decarboxylation. The reason people have been smoking cannabis for thousands of years instead of just eating it raw is because that's what works. And that's what works because when you're smoking, you're applying heat. Initially, that was really the only way to get the cannabis into your lungs, so people thought that's why it worked. But no, it also has the added benefit of decarboxylation, which is required to feel the psychoactive effects. So this is what we do and how we can figure out whether a product has been decarboxylated or not. What we do, we take a sample in, whether it's bud or an oil, right, or a decarbed oil, like Rick Simpson oil, or an edible, or virtually anything. And what we do is we aggressively extract all of the cannabinoids from that sample, and then we process that, and we process it, and we dilute it, and then we inject it on our HPLC, which is high performance liquid chromatography. And what that does is it separates all of the cannabinoids from each other. That's what this was injected like yesterday, and this is a vial that contains 10 different cannabinoids in it. There's that guy right there is CBN. This is THC. This is THCa. All right, that's CBC. There's CBDa. There's CBD. There's CBGA. We do a bunch of different cannabinoids. Okay, and the point here is that you can see individual molecules and how much the size of the peak indicates how much of that molecule there is. All right. So if somebody brought us a flower, this right here is not very typical, but it's a flower, right? What we see here is, well, this molecule is there, right? What is that? THCa. We see this molecule, which is CBDa. This is about a 1-to-1, close to 1-to-1 CBD to THC flower. This is where THC comes out, there's very little THC compared to the THCa and the CBDa in the flower, because the flower doesn't produce THC, it produces THCa. Okay? This is another sample, a different sample. This is a decarboxylated edible. Okay, this is an edible from which we extracted all the cannabinoids. And what you see here is that there's very little THCa and a whole bunch of THC. And this one is actually CBN. There's a little bit of CBN creeping in. Okay, so what's going on? Why are we? Does that make sense? You guys heard of that? Why is there CBN? What is?
First one got cooked too well.
Well, yeah. So yeah.
Right.
It's an oxidant. It oxidizes. The THC gets oxidized and converted into CBN.
That's right. That's right. Exactly. So we do have, very often we focus on this one reaction of THCa. You apply heat, you get THC. However, anytime you put a molecule, a pretty complicated molecule, into heat, into the presence of heat, it's going to maybe react and produce something else. Okay, so THC with heat gives you CBN as well. And not just CBN, it actually gives you a whole bunch of other stuff. It does start breaking apart under heat. So when you are decarboxylating from THCa into THC, you want to be very careful, because if you apply a lot of heat, you are destroying your THC molecule and you're making other things, such as CBN.
Do you know what temperature that happens at?
It'll happen at least a little bit at every temperature, but the point is to control it. Every reaction is, a chemical reaction. When a molecule becomes a different molecule, or two molecules become a third molecule, or one molecule falls apart into two molecules, all of that happens. It's all real. It's always like a real thing falling apart. In this case, we have a THCa molecule and it falls apart. And how fast that happens, we can do some experiments, and people have done a lot of experiments to figure out what makes it go faster, what makes it go slower, how does this reaction behave, so I want to talk a little bit about reaction rates just for us to understand. A zero order reaction means that it doesn't matter how much of that molecule there is, the reaction happens at a certain rate. So if you take a gram of THCa, just pure THCa, and you leave it at a temperature, if it was a zero order reaction, then every, say, hour, you have a certain number of THCa molecules converting into THC molecules. A first order reaction is a little bit different in that the rate depends on how much of the material you have, how much of that molecule you have. If you had a gram of THCa, the reaction would be faster than if you had a half of a gram of THCa per volume. It's concentration, not gram, but gram per mil or something. Okay. So a first order reaction, the more of that molecule you have, the faster the reaction. Therefore, after a little while, the reaction is going to slow down because you're running out of your molecule. Whereas in a zero order reaction, that rate is the same whether you are at the beginning of your reaction or at the end. Okay? And the second order reaction is even more dependent on the amount of that initial reactant than in the first order. That's just a very, very simplified way of doing it, of talking about it. We're not going to do calculus today, but it does involve a little bit of calculus. Turns out that decarboxylation is, in their case, it was in the solid phase. What they did was they took bud, they crushed it up, they put it in under vacuum, and they heated it at different temperatures. They looked at how quickly the THCa disappeared. So they took it out every 5 minutes, and they saw what was left over. And what they saw was that it's a pseudo first order reaction. It's something that I think you guys have all kind of seen, in that the amount of THCa, you have to really work for that last little bit of decarboxylation. You can get 50% of it pretty easily. You get 75% of it. It's not as easy, but you can do it. To get up into the 90s is difficult. Okay, you're now treading some really fine lines to get to get up there, you have to make sure you're not losing THC. There's just a lot more involved. But getting that last little bit of THCa to convert isn't as easy as the first little bit of THCa. Okay, so it does seem to depend on how much THCa there is to begin with. You know, they're confirming that at higher temperatures you get faster decarboxylation than lower temperatures, and this is linear with respect to the natural log, which is a fancy way of saying first order. You can model this, take a natural log, which is a mathematical function of this, you get a straight line, and that's what they're seeing, is that you get straight lines of the natural log. It's first order, is the short of it. Alright, there's also this really famous little graph that many of you may have seen. It's available online. It shows you the effect of heating time and temperature on the amount of THC present. And the reason I bring this up is that generally there is a maximum, and then the THCa begins to go away again. And that little spot at the top, that pinnacle, that is very hard to achieve. A lot of people either are below it or way above it, and they have full decarboxylation, but they're really like over here and they've lost a whole bunch of THC. Happens all the time. And it's okay, you still, you have converted all of your THCa, and our instruments will show that there's no THCa left, but you don't know whether you're at your peak. So in a perfect decarboxylation, you've lost 12.3% of your weight. So if you start with a gram of THCa and you decarb it perfectly, you're going to wind up with 877 milligrams of THC. Same thing with CBDa to CBD. That's if under perfect conditions and if you know how to weigh properly.
Oh. Hi everyone, so my name's Shanel Lindsay. I'm happy to be here today to talk to you guys a little bit about decarboxylation. So decarboxylation has been near and dear to my heart for about 15 years now, a major part of my life. And so I'm from Boston, I'm an attorney, but also I am a mom, I'm a business owner, but I've also been using cannabis as a medicine for going on 15 years now. And so after my son was born, I got an ovarian cyst, and I had already used cannabis for recreation and loved it. And my doctors were trying to put me on really high levels of acetaminophen, and I was worried about my liver and thought, I hear people out in California and Colorado, they're doing good things with medical cannabis, let me try to make this medicine. And so I was back then just doing what everyone else was, kind of what I consider like back in the dark ages a little bit, which is just plugging away in your kitchen and figuring out, looking online and doing your own methods and finding out like really what works for you and what seemed like it worked. So that's making, butters and oils and other topicals, and I was happy with being able to use cannabis as a medicine. It was very helpful for me, but I was not happy with the processes that I was doing. It was taking a long time, it was smelling. I really wasn't happy with incorporating a lot of butter and oil into my diet at that point. I was in my late 20s then, and wanted to be healthy and that kind of thing. And so it was really a blessing that medical cannabis came to Massachusetts, and then getting access to a place like MCR where you have a lab. And so now we're in the space where there's opportunity to do testing, and I think a lot of people in this room are into that kind of thing, is understanding what your medicine is all about. I think that we all know cannabis is a very powerful medicine, so it's so amazing you can almost kind of like slap it together and it will still do a good job. But I think that now, as the medicine's advancing and as people are trying to get more into the science of it, there's another deeper level that you can go and try to figure out exactly what's going on, and so we can take it from, hey, this kind of holistic thing into a real respected piece of science and medicine, and that's what's required of it to get it there. So for me personally, when I encountered the lab, it was an opportunity to really get some hard data and some answers to the avenues that I was pursuing in order to try to bring cannabis medicine or figure out how to best access it. And so at that time, so I wanted to today share kind of some of those things that I've learned and discovered along the way with the data and science, and then hopefully, answer some of the questions, and I'm sure open up a whole new can of worm of questions with some of the things that we've encountered along the way. So just to start, I wanted to kind of talk about how I've been approaching cannabis and decarboxylation. It really has been from the side of the cannabis flower and decarboxylating the flower and the materials that come from the flower. We saw some extractions being decarbed, and my work has taken me into extractions as well because people are using them and they want to use them with the Nova. But when it comes to the way that we've approached it in the kitchen, it's been to actually activate the plant, and then in my opinion you have a lot of different ways to use it afterwards. You can smoke it and get an enhanced smoke out of it. It's really simple to kind of make easy topicals and edibles and infusions and other things like that. And so when I began doing and working on this, it was really with crock pot, and that's a really popular way that people use to decarboxylate. The heat and the temperature is the situation is where you really can't hurt, it's harder to hurt the cannabis than using an oven or something with a more variable temperature, because the crock pot and the liquid in the crock pot is going to boil at a more even rate. And so going back to using bud and flower, another point there is we're starting to encounter a lot of cannabis medicine that doesn't have solvents in it, like rosin, using keef, and some other materials. So I do think it's important to understand how decarboxylating, the nuances of decarbing bud versus oil and other things like that. So back to the crock pot. So when I came in and first started testing crock pot here at MCR, I was very surprised, because what I had been doing was using the crock pot for about an hour and a half, making butters and oils, or another really popular way is taking a bud and sticking it inside a bag and then sticking it in the crock pot and letting that boil. And what we found was that it's very, very difficult to get full decarb using the crock pot. It takes a long time, and this is really a practical demonstration of what we saw in the scientific pseudo first order, which is it's really, really hard to crank out that last bit of THC. And so this is these illustrations and the pictures you see is actually from a decarb guide that we put together, which is kind of a synthesis of some of the testing that we've done here. That's available online for anybody who wants to look at it, so I will let you see that. But I also have some of the raw data behind this that I thought would be cool to share with you guys here, since we're doing kind of a deeper into the science decarb. So I'll just talk to you a little bit about it first. You can see, actually we'll just go to the raw data. So you can see that with your increasing time, you are not really much more increasing the THC that you have there, and even when you're moving from 75 to 90 to 105 minutes, you're still having significant amounts of THCa there, and then you're looking at almost 2 hours over heat and starting to see a degradation in the amount of total THC that you're getting there at the end. And sometimes when you see variations, it can be from the natural variation in the flower. When you start to see it multiple times, you can think it's from degradation. And so that avenue seemed like a dead end in some respects for getting good decarboxylation. Number one, because of the time constraint. When you're talking to people about decarbing and making medicine, they want that medicine done pretty quickly. And so when you're talking about a couple of hours, and that seemed to be an issue there. But also people want full decarb. And so then I think the next thing was to start looking at the oven and the toaster oven and doing testing on that. So when you're talking about decarb, you're talking about the time and the temperature, and you're also talking about atmosphere. You're seeing a lot of oxidation from CBN happening from oxygen being present while decarbing is happening, not just from excessive heat there. And so when you're looking at, if we're going back to the crock pot here, and we're talking about temperature, the temperature that water boils at is 100 degrees Celsius, so 212 degrees Fahrenheit. So you're getting, again, good decarb after 60 minutes. You're getting, you're still having 36% decarb THC left. and you're not getting much better at 90 minutes. You're starting to crank out a little bit more, but over here we saw 20% loss here. And so this temperature, you're thinking, okay, 212, why don't we just try to crank it up a little bit and see what we can do in an oven. And we also saw higher temperatures when Michael was talking, 110 degrees Celsius, so right around the 240. So we started doing experiments on an oven and toaster oven to see what those would yield. And you can get that higher temperature, but you're starting to run into the fluctuation in temperature and not being able to control the temperature with the oven. So on one hand, you have the water, it's good, but the water is never going to boil to a high enough temperature to get you where you want to be. And then on the other side, you're having an oven where you're having the fluctuations in the temperature. And the other thing to note about an oven or a toaster oven is that you have the kind of the position of the heating elements being a challenge, and getting even heat. Because if you're having heating elements, everybody knows a toaster oven and an oven, the heating elements are kind of up here, and then you have this middle space. And so even if you know what your oven says it is, there's going to be fluctuations 10 or 20 degrees in between. So it becomes very difficult. I mean, people on the dispensary level, when they're decarbing keef and that kind of thing, they're using ovens with multiple temperature sensors, and people are monitoring those. So it becomes really kind of labor intensive there. So a person at home, we were finding that kind of doing it at home was difficult on the oven side. And you can see though how sensitive the process is. We're only talking about the difference between 212 and 240 degrees Fahrenheit. After doing those testing, what we did with these guys here was just more battery testing of different temperatures, really honing in on that temperature, right, somewhere between that 110 and the 100 degrees Celsius, and ended up finding what that right temperature is, not over 103 degrees Celsius, and developing a device that does that. And this is a sample of one of the tests. I brought the raw data from another test that we just did. So you're getting full decarb there, and you're not getting degradation to CBN, and it's easy for patients to do. So one of the things that we saw that was really important was getting that even heating as well, which is why we kind of moved away from doing something that was a heating element like an oven, and really have a heater surrounding the entire, so it's like a silicone heater inside here surrounding the entire cavity, so you're getting that even heating, and then using multiple sensors to control that heating blanket, and then using an algorithm that makes sure that the sensors are getting to the right temperature every single time, and monitoring that and rolling through. Along the way, we ran into people starting to use the decarboxylator for extracts. And so here's just an example of BHO being decarb. What we noticed with the extracts is that we're noticing a more concentrated product at the end, likely from boil off of residual solvents, or again, this is BHO in this instance. So in my personal opinion, what I've seen, it seems like there is a little more give when you're decarbing with extracts, when something is already in that oil. I just think that Mike made a great point though about using high temperatures with oil, and really there needing to be more data on what loss is happening there, because one thing we see in decarb is that you're quickly getting lost there. So I'd like to, I think the future of decarb is really exploring kind of the fixative property of the oils, and then also really doing comparative tests to see, hey, the THC will be there. And we see that a lot, like there'll be a degradation of THC and no CBN. So you might think at first glance that you haven't degraded, but there's half the THC that was there before. So it's going somewhere, it's just not being picked up as something that is coming up on the test to get to that full decarboxylation of THC without any degradation to CBD, and to CBN, and we've done that. And I think it's a combination of the lack of oxygen coming in here, so no oxygen, and then a really, really, really tight temperature control, where you're getting to that 100, and again, that's what, the algorithm varies, but it does not go above that internal temperature of 103 C, so 218 Fahrenheit, and then there's an outer control on the outer sensor as well. So it's a, it's a cycle that it goes through, and it's like a proprietary algorithms work really hard to get that, but that's the time and the temperature parameter that you need to be at and below. And it's very, very difficult to get there, you know, when you're just using kind of the imprecise methods of the oven and the toaster oven, or, you know, or the crock pot.
Do you find that it works because of the volume of control that you have, the size? You can't go larger. How much material?
Yeah,
size
so
can you
the we get it. So you can fit as much material in here as you can fit in here, and you can also decarb just a teeny bit too. So if the
But it doesn't matter if it's touched, it's packed,
no,
or
it doesn't matter. You can fill it up. We say don't like jam it in there, but you can fill it. We do get a you know, often ask for a commercial size, a bigger size, you know, and that's the next thing. We probably will come out with a commercial size, but part of this and part of my personal mission is to give education and power to people and patients, you know what I mean, on the patient level. And so for them to have a device that they understand, that it's small, and that people can start understanding you need so little to actually get your medicine. Like, that's the thing, people are using so much now because their methods of decarboxylation are so poor that they're having to use, like, I hear people using, like, you know, 7 grams to make a batch of cookies. That's like ridiculous, you know, when you're talking about, if you're looking at this sample here, you know, you're talking about 19% THC in the bud that's coming out of that. That's 190 milligrams in every gram. Like, think about how many cookies or things that you can, how many 20 milligram doses you can make with that in 1 gram, 20, you know? So people, they can realize that there's a lot of utility here, and so I think that's part of it, and especially important for people that are, you know, don't have a lot of money and don't have experience with cannabis. So
that size, of how long then does that process take?
So it's an hour and that's enough. Thank you for pointing that out. So it's an hour and 15 minutes for total for heat up and cool down time, and that's the thing I think, you know, you have to balance when you're thinking about decarboxylation. You want it fast, but the temperature is, you want to keep it as low a temperature as possible. There's a reason why people want to try to do it in, like, sous vide or in the crock pot, because the temperature is low enough that you're keeping terpenes intact and the bud isn't burnt up, you know what I mean? And so that was always our desire, to keep that temperature as low as possible, you know, but the water boil method is just not high enough. So pumping it up just a little bit, but then keeping it low enough, you know, you're getting the timing of, you know, like I said, the hour it's really an hour for the cycle, but the heat up and cool down time gets you to an hour and a half. Proper drying and curing really doesn't do significant decarb at all. So here's some examples of dried and cured. So some of them you have 0, some of them you have 1. I even went through and did a little more searching on the MCR site. I didn't see anything that really was above 1.1. Some of them I saw that was higher, and I consider that not very good curing process. You know, excessive heat exposure, you know, being in a hot car, being in a hot room, you know, things that you don't want to be holding your cannabis to. So that was just
How long of a cure was this that you using this?
Yeah, so some of these were around for a couple of months, some of them were more fresh, but it doesn't, this is just a mixed bag of, from caregivers and growers that I respect and do a good job.
Right, okay, yeah, it's like a month to a year old,
Yeah,
probably.
I wouldn't, yeah, probably around 6 months.
Have you run concentrates in it?
Yeah, so this was the BHO concentrate that we did. So here's a starting, before the decarb, and again, this is an example that BHOs properly purged and aren't decarboxylated. So you have 71% THC, 80%, almost all of it. So I think this one was like, that calculation is like 3% decarbed or 5% of total. So 1% of, is that right? 1% of the 80. So then we're seeing the conversion here. Obviously, when, as Michael mentioned before, when you decarb, when that THC loses that molecule and the THCa loses that molecule, there's a conversion, there's a loss there, so a loss of 13%. Yeah. So what we would see, expect to see here is a maximum of 71, even though you see THCa is 80%. The maximum, theoretically, there possibly could be a 71% once it's converted. So you multiply the THCa by 0.877 and you add that to the THC. And we saw that this one, when it came out, it was a little bit more concentrated again, I think from boil off of residual solvents.
So when you use the concentrates, obviously there's a time difference.
No.
As far as run, so you can fill that thing up to the top with concentrate.
Yes, and I wouldn't fill it to the top because it would bubble, but
right.
yes, you could
but
fill
you
it.
Fill it to whatever.
Yes, and you can.
versus this much or this
Yes.
much. And it'll be the same amount
Yes.
of time to decarb the full amount.
Yes.
of-
And this was at lower, and this is at significantly lower temperatures than we were doing over here. It was a little bit longer, time frame, obviously. But again, we're not seeing loss, and I don't know what the comparison for loss is for this. And again, the concentrate isn't our main focus, even though lots of people have been using it for concentrates, and we're actually coming out with the silicone sleeve to put in here so people can, because we said you have to put the concentrate on a sleeve, you don't want it to be scraping it off the bottom of here. So let's see, we're talking about CBD. Okay, so CBD, yes, it does take more energy than THC, but what we found is that it's more volatile than THC as well, and it requires tighter control. And so here's just a little sampling of testing that we did at the 105 and 110, and I have to say I completely disagree with the Swedish paper that said that 110 for 110 for 110C for 110 minutes got them the full decarb. Like I said, we get the full decarb at 103C for 60 minutes as part of our, so we never go higher. We never go higher than that 103, and then we're getting there. So I think, preserving more terpenes at that point, and you're not, burning off the product. So here's just an example of CBD. So this is a high CBD strain. Here you see we barely have any THC at all, but, and almost 20% CBD. So this is like, I think Auto 2, but it was a, this was a push, and you can see here, we're starting out with a max of 17, and we're already down to the 11%. So we're there's loss here, even at the 105 at 60 minutes. And so this is from the testing and the work that we've done. The CBD is more sensitive, but it's also, I think, going to be dependent on whether you're having a mix of THC in there as well. What I've seen is that the ones that are very, very, very high CBD are a little bit more, are more fickle here. So, and then you see we still don't have full decarb at that point. Pretty, we're getting there, but not full. I'm wondering too if with CBD it's going to be necessary to mix with an oil with the high CBD strains and then decarb, for the fixative properties of the oil. That's something we're going to be looking into. One thing I happened to come across recently was, and I ran into it before, but I saw that it recently got granted, and it's a patent for accelerating or limiting decarboxylation reaction in an extract. And I don't know if it has any validity or not, but I just thought it was an interesting kind of something that's out there that I wanted to get everyone's opinion on. So what they essentially say is that they make an extract. In many, many respects, it looks just like any other making an extract and decarbing. And so they start by putting it in an oven, and then they put it in an alcohol extract and start evaporating it off. But the interesting thing is they talk about using a cofactor, B6 vitamin, to modulate the decarboxylation reaction. They don't give any scientific proof or tests or anything surrounding it, but what they do, the part that I thought was interesting, is they said that if you add a specific amount of this B6, that it will essentially halt the reaction at a certain point and stop any further decarboxylation. So I could see that if people were interested, I do think that the future of cannabis is after people really understand decarboxylation and CBN and how things work differently, because even we have a lot of people who are searching for CBN in some instances, like vets with PTSD and wanting to create certain things. So I think after we understand kind of the basics of getting to the best practices for getting full medicine conversion and that kind of thing, people are going to start using really tailored cannabinoids in medicine. So when the bud comes out, you can make different things, like here's a toner for your face, and we also have made these sublingual wraps, so you put the bud in it and stick it under your tongue, because I think that sublingual use is really underutilized. I think it's a great way for absorption, a lot better than digestion for most people. And so we made those wraps, and we also have these capsules. So the decarb guide is at www.tinyurl.com/decarb guide. a decarb guide that we came up with about myths of decarb, and it's based on the research that we've done here. So it just kind of has an introduction and goes into like what is decarboxylation, and you know, kind of discusses some of the things. But here's that graph we were talking about, and I say like, you know, beware of that, because it's just, you know, just beware of the conditions that you're looking at when people are decarbing. Just like, you know, be careful if you see like, hey, here's an awesome decarb product, and there's like 5 milligrams of THC, and you're like, oh, that looks amazing, but what if there could have been 25 milligrams of THC in there? You know what I mean? It doesn't seem so great at that point. So always ask for like before testing, after, you know, compared to the after testing. That's really important. And the DHO extracts, and people think you need to grind before you decarb, and that's kind of a method that people use to try to make oven decarb more accurate by increasing like the surface area. Like you don't have to grind if you're doing like a really precise decarb with the Nova, and grinding it, you know, you're disturbing the trichrome. So if you're going to be able to increase shelf life if you're not doing that. And then fats and alcohols, and using those to prepare cannabis. So
tinyurl.com.
tinyurl.com/decarb guide.